Whenever we study so far, we have always taken the force applied by one surface on the object to be normal to the surface. In doing so, we have been making approximations. Therefore, we have been neglecting the very important force as wise the frictional force. In this lecture, we took the at the frictional force in the previous situation. In this lecture, uh, we, when we talk about friction, we should mean the frictional force between two dry surfaces as this. This is known as Coulomb friction. Frictional force also exists when there is thin film liquid between the surface and within the liquid itself. This is known as viscous force. We will not be talking about such force and will focus on that attention on Coulomb friction. Therefore, friction force between two dry surfaces only frictional force always oppose the motion on or tendency of an object to move against other object at, or against a surface. We discussed between two kinds of frictional force, static and kinetic, because it is obviously that kinetic friction is force slightly less than maximum static friction force. Let us now perform the following experiment. Put one block in the rough surface and pull it by F force, as shown in the figure 1. Since the force F is the tendency to move a block, the frictional force acts on it and opposes the direction of applied force. All the force acting on the block are shown in the figure. Note that I have shown the weight and the normal reaction acting on the different points of the block. And I leave it to you for think why should be weight and normal reaction is not along a vertical line. It It is observed that the block does not move until the applied force F reaches the maximum F max. Yes. Thus the F equals to 0 up to F max. Yes. To the frictional force adjusts itself. So the much sufficient and stop the motion was observed by the coulombs. The F max is proportionally normal reaction, and the surface of the object you can observe all the trying push the table across the rod, and heavier the table larger the push required to move it. This is right. F max is directly proportional to normal reaction, which gives F max equals to mu s s into n, where mu s is also known as coefficient of static friction. It should be emphasized again the maximum possible values of frictional force applied when the object is also to stop, otherwise the frictional force could be less than just sufficient to prevent motion. We also note that frictional force is independent of the area of contract and depend only on n. As the applied force F is goes beyond to F, the body start moving. Now the experience slightly less force compound to it. The force seems to be even the coefficient of kinetic friction, and at low velocity the constant and but decrease the slightly high velocities is a schematic plot of friction F as shown in the function of the applied force as shown in the figure 2. Values of frictional coefficient for the different materials varies is from 0 to large 0.9. A quick way to estimating the values of friction and in is to the motion of the object inclined plane and free body diagram as shown in the figure 3. Since the block has tendency to slide down, the frictional force point on the inclined and plane as long as block in equilibrium, which gives mg sin theta is smaller than maximum friction, which gives mg cos theta equals to normal reaction. Also the theta is increased, mg sin theta increases. When it does to pass the maximum possible value of friction F max, the block starts sliding down. Thus are the angles at which the slides is down. We have mg sin theta equals to F max equals to mu s n and mu s mg cos theta equals to mu s equals to tan theta.